for this delay. Um, so this is our last topic, database recovery techniques. I kind of gave you a quick introduction to it last time, so that I will be going much deeper in this session. Okay, so first of all, what do we mean here by recovery? Any idea what recovery means? Yeah. Yes. Very good. Yes. So, failures could happen, like many types of failures. It could be application errors that can cause failures. It could be operating system errors, a memory problem, hardware problems. It could be a disk crash. Any of these problems, we need to recover from them. And there are many techniques based on for each type of scenario. There are many techniques to recover. Failures, of course, include also disaster recovery. If let's say there is a flood or some kind of fire or any other major disaster, you still need to think about it and have some mechanisms in place to recover. So recovery is all about ensuring business continuity. You don't want to interrupt your business. You want to ensure that you can keep going and you can recover. So this is what this is all about. So in terms of asset properties, which properties are concerned with the durability? Yes, the durability property. Also the atomicity, as I will explain. The mechanism for recovery is used for both achieving atomicity and achieving recovery, as we will see shortly. Okay. So here is the motivation. Why do we need a recovery? So database need to have built-in recovery mechanisms to be able to deliver those promises that we talked about from the start of this course, the atomicity, the asset properties. In this case, I am particularly talking about the atomicity and the durability. Remember the concept of atomicity. What does it mean? All or nothing. So we group operations as one unit. If something happens in the middle, some exception happens in the middle, so what do? We roll back. Now to roll back, what do we need to do? What do we need to have to be able to roll back? Sorry? Yes, we need somehow to record the actions that has been taken before. That's the only way to roll back. To undo, you have to record the changes as they happen. And I gave you the small example of Word. So for you to do undo in Word keeps track of your changes. And then you can basically undo them or redo them. So that is the idea. So atomicity, to be able to do atomicity is, if you think the main goal of atomicity is not to do partial update. You don't want to end up doing part of the operations and not completing the remaining. So if something goes wrong and you are not able to continue to the end, you must undo what you have done to keep the database consistent. And to be able to undo, you have to keep a record of the changes that has been done as you go. And those records in the context of a database, keeping track of the changes done. When I say changes, it could be inserts, updates, deletes. It could be schema changes. Any change to the database, any change gets logged, gets registered in a file, basically, to help us do atomicity. Also, it will help us achieve the durability. Now, I started explaining this last time. If you remember, there is a trade-off. There is a trade-off between this consistency, keeping the database consistent, and also between performance. Okay, so database need to ensure a good response time, or the shortest response time possible between the time you issue the query and the time you see the results. Database strives and does its best to reduce that time as much as possible, using various techniques that we have covered in this course. Among them is what the database uses to speed up performance of the queries, the buffer. Among them is that the database is equipped with a buffer manager, and that's like the intermediary stage where reading and writing takes place. So when you run a query, the blocks that has the data you are looking for, they get loaded into the memory, into these buffers. And then when you start doing any changes, those changes are done on those copies that are in the buffer. Now, database is not in a hurry to push those memory buffers to disk. So it tries to keep them in disk as much as possible. But if it does so, it is running the risk that if the server crashes for some reason, the changes that are in memory will be gone, lost, because we know memory has one of its properties, it is volatile. So to have some kind of a nice balance between the performance and the durability that it has promised the users, so what it does, it keeps track of the changes made in a log file. So in this scenario, when you commit a transaction, let's say you have placed an order. So those of you familiar with this, maybe some of you are using it for your project. So order is made up of ordered header, some information about the order, and the order items, many items, and maybe a payment, let's say. So to create an order, you have to at least do 3 inserts. So 1 insert in the order table, a couple of inserts into the order items table, and maybe an insert into the payment table. And maybe you can even go to the product catalog and reduce the quantities. That's another operation you need to do. All of this has to be 1 unit. So when you do all of this, it will be done in memory. And then these changes are recorded in the log. And then say the log, when you commit, the log will be saved to disk. Before database tells you, I am done, I have done all the work, before it gives you that confirmation, what does it do? It saves those changes to the log. Not the actual data blocks, but the log file itself. The log blocks, or the blocks that record the changes, will be saved to disk. And then it will declare the database as, it declares the transaction as successfully completed. But once it declares that it is successfully completed, it gives you this assurance of durability. Now imagine the power is kind of lost, like the server, let's say, restarts for some reason. Then what will happen? If the server restarts, the changes that are recorded in the buffers in memory, what will happen to them? Will be lost. Okay. And now, when you restart the server, what the database will do? We'll need to recover. Basically, that's the verb. We'll need to recover using what? Using the log file. So what is the recovery protocol? What it will do to recover? So replay the log. So the transactions that has been committed, they are fully committed. What the recovery manager will do to them? we replay them, we re-execute them. And the transactions that didn't make it to commit or roll back, it will roll them back, it will undo them. Because remember, this will become clearer as I move forward, because there is another process called checkpointing. So the database might decide to store the log or to save the log before the commit. So a log might have some entries that are not committed. So those that are not committed, we have to roll them back. So visually, this is the time. This is time goes on, and these are the concurrent transactions going on. So, and this is at certain time there is a crash. Maybe somebody plugged power accidentally or whatever happens. So when the database, and suppose these changes are all done in the buffer, and they are not done in the physical data files yet. They are only stored in the buffer and of course in the log. So these in blue are committed, means they have been fully completed before the crash. So what do we do with these? When the server restarts, it will go through the log and replay these 3 that has been committed. Because the assumption here is that the dirty pages where the changes has been done might not have the chance to be saved back to disk. So that's why we have to replay them from the log. Now the ones that were in progress, they didn't finish yet, but they managed to somehow make up their way to the log. Then these we have to roll back. What's the reason why? What is the reason these didn't make up? Why these incompleted transactions are also shown up in the log? Why do you think? Don't we just save the log when we commit? Or why we see this in the log although they are not finished? So if it's not completely done, we should not have even seen it in the log. So when we recover, the log does not have these entries. Yes, of course it does record it, but why does it need to push it to disk? Yes, every change is recorded in memory. There is no problem. It is recorded. But when do you think the database decides to push the log to the disk? Sorry? No, not really. At commit time, when a transaction wants to commit, before it commits, what does it do? It pushes the log to disk. Because just in case something goes wrong, we want the ability to redo. So I need to store the changes back to the disk. Now, remember, the log file is shared across multiple transactions. Not every transaction has its own log file. Okay? So when this one has committed, other transactions have just started. They just had a couple of operations. They didn't commit yet. So when we save the log might have entries from transactions that have fully completed, like committed, and others are still in progress. So the database does not maintain a log per, let's say, per table, or a log per query, or a log per transaction. It's one shared log where all the logs get recorded. Okay, so let me just jump just to make it a little bit clearer and just show you concrete examples how it looks in a real life, in a real server like SQL, something like SQL Server. So
Doctor, how do the files managed across different transactions? Is that might cause a conflict to update
No, not really. We will see. As we go forward, you will see kind of examples, and it will be very clear that multiple transactions are write to the same log. So basically a log is kind of, you think of it as, let's say you are doing some work. And whenever you do any work, you first record it. Let's say you want to, let me give you an example. Let's say you have a paper or you have a report. Let's say a report. And then you submitted it and you got some feedback. Usually when you resubmit it, let's say a paper, when you resubmit the paper, usually the editors, they ask you to provide them what are the feedback that you received and how you address the feedback. So each feedback, you will have to say how did you address it. So while you are, let's say, doing changes to your document, you also record in a separate file what are the changes you are making. For example, it says to you, you have not cited, one of the reviewers told you have not cited this important paper. Okay, so you go and change the document to cite it and to include some discussion about that paper. And you also record it in a log to say, oh, I have done it. So basically, and that log, you might be doing different things. Maybe you are changing the implementation. You also come to the log and say so. So log is recording any changes database is doing, it gets recorded. It could, and the log entries could come from different transactions. Maybe it will become clearer, like before I jump to the more details. Let me just show you how a log entry looks like, and then it becomes very clear. So log entry looks something like this. It says transaction T1 has started. T1 has changed A, the old value was 8, and the new value is 16. T1 has also changed B, the old value is 8, the new value is 16, and T1 has committed. So every entry has the transaction that asked for the operation, what is the value that has changed, and what's the old value and what's the new value. So let me show you another example just for you to get the idea. So in here I might have multiple transactions. T1 started, T1 did this, T2 started, T1 committed. So this is how a log entries kind of look like. So every transaction, when we record an entry in the log, we also record that entry belongs to what transaction. And you can see here, we only record the changes. We don't record the reads. Because the reads, why not? Why don't we record the reads? They are not changing the state of the database. So we don't record the reads. We only record the writes, the changes, inserts, update, deletes. So it will become clearer as we move forward, but this picture, you can keep it in mind so you kind of know that a log is shared. And there is no confusion because each entry, we know from it belongs to which transaction. Okay? And basically the idea here, the transactions that have not completed, we don't find a commit for them, we undo them. The transactions that we find they came all the way to commit, we redo them when at the recovery stage. Okay? I will explain that. Yes. For now, I just wanted to give you like a big picture of how log looks like, so you can follow in a better way. Okay. So let me just jump to this example here. So first, there is a simple database here. It comes with SQL Server as an example database. Let me first show you. A database is made up of files, and most databases will have basically at least two files. One is the data file, and the other one is the log file. Okay, even when I create, let's say I go here and create a new database, it will ask me, give me a name, and then it tells me where is the data file and where you want to store the log file. Okay? And basically the database will maintain 2 files for each database. The database management system will maintain 2 files. One, it stores the data, and another file, it stores the log of the changes. Now, the reason why they are 2 files, why do you think? Why do you think they are separate files? Database, in fact, allows you to put them in different places. Sorry? Yes, kind of. Which one do you think is more important to really take care of more than the other? Kind of both of them, of course, are very important. But usually, let me tell you, in a real life, like there are people, they call themselves administrators, and their job is one of their jobs is to do regular backups. So database, any production database will have some kind of regular backups. So let's say at least overnight, and maybe one or a couple during the day. But the minimum is that if something goes wrong during the day, at least we have the backup of last night. So how much we will lose? We will lose from the last backup until the crash time. Okay, but where is these changes that has been made from the last backup until the crash time? Where they are stored? In the log. So for a running database, assuming that there is a backup, assuming that there is a regular backup, at least a nightly backup, which of these files is more important? The log. Because the data file, you can kind of recover the last known copy from the backup. But whatever the user have been doing, let's say the crash happens at 11 a.m. Whatever they have been doing from the time they came to work until 11 is lost, except if you take care of the backup file. So that's why the backup, you have to put more effort into it. Both of them, of course, are important, but backup, usually people will, sorry? No, not static, like, it's more dynamic. So the log, basically any change you do, it's getting recorded there. No, in terms of recovery, in terms of being able to recover from let's say a crash. So usually in real life, you will put it in some kind of, you remember RAID 1, where you have like mirroring, at least 2 disks, you have the same copy on the 2 disks. So if one of the disks crash, at least you have it in the other one. So usually people put the data in a RAID 5 RAID, an array of disks, while the log is placed in a RAID 1, because the log is more critical, and also we write to it more often than the data file. Okay, so usually the key idea here is not to put both of them in the same place. In real life, you put them in separate disk kind of disk arrays, and then you provide more redundancy for the log, because the data itself, it can be recovered from the backups, but the changes from the last backup until the crash time, you can recover them from the log. But if you put the data and the log in the same disks, you are running more risks. Okay, because the data can be lost, completely lost. Why? If you just have the log and have the last night's backup, you can recover until the time of the crash. And we will see further ideas why is that. Okay, so what I will be doing, I know it's not very clear because I couldn't expand this, because this is a remote session to the server, to the SQL server, because it's not installed in my machine. It's a remote server. So let me just, this one is very, very nice utility. This is more for kind of real-world investigation of performance issues. So what this utility, it's called a process monitor. It comes from Microsoft. Microsoft has a lot of tools. They call them system internals for monitoring and for debugging and investigation. One of them is called the process monitor. And what this one does, you can monitor any program, what files it access, what registry entries it access, and so on. So in here, I'm just asking it to watch this location. It's this location here has the database files. So I want this tool, whenever I read or write to data file or log file, I want to see that those reads and writes. Okay? So let's have a look. All right. So to start from scratch, what I'm doing, nobody does this in a real world, in a real database. Let me just show you. There is a command in SQL Server that allows you to clear the buffer. So you want to start from scratch. Like buffer always has the last blocks that are used by previous queries. So just to show you exactly what's going on, I'm going to clear the buffer. So we don't have anything from the buffer. So whenever I will do a query, it will go to the disk and bring it to the buffer. So let me run this. Okay, and then have a look at this. What I will do, I have a table here. It's called sales table. I will select all the records from that table. Have a look at the, so let me try to do it side by side. So far, no reads. Have a look when I query this. So these are basically the, if you look carefully, I know it's a bit small, here is the MDF file has been read. So to answer this query, these blocks has been read. If you look here carefully, it will show you the parts of the file that has been read, the blocks that has been retrieved from disk. Now, when I run the query, these blocks has been read from disk, and where they are now? In the buffer, on the server memory. In the buffer, we have these blocks. So let me now go here, and basically I will clear this. So we see what's the impact of the next execution. So let me just clear. So if I rerun this query, what do you think? What is the expected behavior if I rerun this query? Sorry? So no, I cleared it before. I didn't clear it again. So to answer this query, the database will only need to read from the buffer. Does it need to go to disk? No. Of course, provided that there is enough buffer blocks to store the blocks that were used to answer the previous run. So let's try anyway. So I'm selecting this, I run it. You see here on the right side, were there any physical file reads? No physical file reads. You see? And if you look carefully, basically the query execution will be very, very fast. Much, much faster than the previous one. Okay? That's why queries, the first time you run it, subsequent times is much, much faster. What's the explanation of that? Because the data blocks that used to answer the previous execution are still in memory. That is the idea. Okay. Now, Also, another less important factor is that the execution plan is cached. Database does not need to go and rebuild the plan, if you remember the execution plan that the database built. So here, it is able to answer it without going back to the database. In fact, let me see if I can do this, where product ID equals 7, I think there is products called 780. Let me just run it. See here, it had to go to the disk. But most likely, because it had to go and query the index. Not because it needed more blocks, but because it had to go through the index retrieve. Now, if I clear this one, if I clear this and I run it again, no need. It just brings the result back because all the blocks are already in memory. Okay? All right, so now let me now, is it 780? Yes. Let me now begin a transaction. Okay, have a look. Have a look at this side here. What I will do is I will begin a transaction and update all the sales for product 780 and change the date to current date and time. Okay, so definitely I know that everything is in memory, so there is no reading. All the data that will be affected by the query is already in the buffer. And the proof is when I run this, there is no physical data reads here. Okay, now, so based on the discussion we just have, when I run this, what do you think? What we will see? So do you think okay, what do we expect to see? Changes of what? So that when I do this update, what will happen? In the buffer, yes, it will update in the buffer only, not in the disk. Okay, and the entries will be added in the log. Basically, the log, yes, the changes will be recorded in the log, but not in the. So the changes will be recorded in the log. Sorry, the changes will be recorded in the log and in the buffer, but not in the actual data blocks. Not in the data blocks. So any movement we will see here. Okay, let me just clear this one. Okay, so let's run it and see what will happen. Okay, run. So you can see it did some extra reads, but the writing, it did only writing to the log. Can you see there? No writing. This is it read from the data block, but it did not. It only wrote the log. Although it did not, it's not a must to record it in the log yet, because I didn't commit yet. But the server really takes care of the log, just in case. So it just periodically stores the log, even if you have not committed yet. Okay, so let me just rerun my query. If I rerun this query, what do you think? What will happen? If I rerun this query, let me clear this. I just rerun this query. It will only read it from the buffer. It will not read it from the disk. And you can see here, if I scroll here and go to the date, it has been changed to just a few minutes ago. We are 1 minute ago. 6002 and this is 601. And this change is only happening in memory. It did not make its way to the disk yet. Okay? Now, have a look at this. When I commit this transaction, what do you think will happen? Which one will be stored to disk? The data or the log? the log only. The data does not get stored to disk yet. Okay, so let me show you. So if I commit this transaction, which means I make this transaction final. So here it is, I execute it. Can you see here what happened? Where the change happened? In the log only. What about the data itself, the changes to the data itself? It's still in memory, not in the data file yet. So you see here, database is not in hurry to save the changes back to the data file, because it is confident through this small log file. If something happens now and the server restarts, okay, or anything happens, we can recover this change. When the server restarts, it will look at the log file and go through the log file. The transactions that are committed, it will redo them. The transactions that are not committed, it will undo them. That's basically the idea. Okay. Now the only time, when does the database takes those dirty pages or dirty blocks on the buffer and push them to the data file? When does it do so? When does it do it? No, from memory to the disk, yes. Yes, when it needs blocks in the buffer to serve other transactions, then it might start taking some of the pages, dirty pages, and pushing them back to disk. So it's basically a delayed update of the data file. Delayed update to improve the performance. That's the idea. But database, it's configurable, of course. You can do a process known as checkpointing. Checkpointing is periodically the database will go and take these dirty pages in the buffer, and it will push them to disk through this process called checkpointing. And I will explain it further. But just checkpointing is usually done automatically in the background, let's say every minute, or it's configurable. You can also control the duration, but you can also explicitly ask for it. So checkpointing is nothing but taking all the dirty pages and pushing them to disk, force writing these buffer pages to disk. So in SQL Server, the command is checkpoint. So let me just clear this and have a look here what happens. When I do checkpoint, you see here, all the writes happen. You see the difference. The log is usually very small. The log changes. It's only maybe 2 blocks we were able to log the changes. But when I actually did the actual writing on the data file, look how many blocks had to be changed. So that's why you see here the trade-off. Database delays this writing because it is confident it will achieve durability through the log. And the log entries are much, much smaller because the log entries only record what has changed, the previous version and the new version. And it's much, much concise. And plus, that log is shared if you have multiple transactions concurrently running. They all read and they all write to the same log file. Okay, that's basically the idea. Of course, yes. Very good point. Checkpointing does not mean remove them from the buffer. Checkpointing is basically the key goal of checkpointing is to reduce the time of recovery. You see here, if you don't do checkpointing, when the database restarts, you have to start from the beginning of the log until the end, and basically undo uncommitted transactions and redo committed transactions. If you have a log that has from last week and you don't do checkpointing, it has to replay the whole last week. Imagine that's like something like QNB, it will take days to recover or hours to recover. So if you do checkpointing means the database now is confident that the changes that were done in the buffer are written to disk. So when the database restarts, the recovery starts from where? From the last successful checkpoint. It does not need to, the recovery does not need to start from the beginning of the log. So checkpointing is just a mechanism to reduce the recovery time. Because remember that business continuity is very important. Some applications, they like downtime of 1 hour could cost thousands, if not millions of dollars or reals. So for recovery time has to be as short as possible. Okay. Of course, let me just clear this one, just to prove it again, just to read from here. I'm reading. See, when I read, did it go to the disk? No, it's already in the buffer. So checkpointing does not remove the data blocks from the buffer. It just checks the dirty ones and pushes them to disk. Okay? So let me rerun this one more time. So all of my data is already in memory, in the buffer. So let me do another update. Here it is. I update. As expected, any changes has been done to the data files? No, only see the log file. And there are some dirty pages. Have a look at this. There is a query. Everything is transpired, something like SQL Server, and I'm sure most of databases have the same facilities. You can ask the database what are the dirty pages you have currently. It's a bit complex query, but anyway. Database like something like SQL Server has what is known as management views. They give you kind of tables, system tables that you can query. Many things. Among them is it can give you the dirty pages. So let me just show you. It knows that for this object, which is sales order details, these are the dirty pages currently in the buffer. And this is the page ID, and this is the object ID. We have 643 blocks are affected by this query. So these 643 blocks are currently in the buffer, and they are marked as dirty. Now, if the database was in a hurry to just, whenever you update it, hurries up and puts them to the disk, then it will have to do 640 block writes. But with the technique of the log, it basically summarizes, kind of compresses all those changes into very concise log entries, and it was able to do them in 2 blocks. Write all those changes in 2 blocks. Okay, and then basically when I go back, have a look at this. Now, if I go and do checkpoint, so let me just clear this guy and do checkpoint. What checkpoint will do? What is the concept of checkpoint? No, not backup. So basically it will take the dirty pages and push them to disk, save them to disk, to the data files. So if I run this, when I run checkpoint, what I'm expecting to see? Dirty pages being written to disk. So have a look. When I run this, have a look. How many, so many block being written to disk. Okay. Now, if I do my query, rerun my query, asking the server what are the dirty pages you have. What do you think? What it will say? There are no dirty pages. All of them has been pushed to disk. But of course, pushing them to disk does not mean we remove them from the buffer. What is my evidence that they are still in the buffer? If I run the query, I didn't go to the disk. They are still in the buffer. Okay? Now, did I commit this transaction? I did not commit. Remember, all of this, and just to prove it, that I did not commit this transaction, let me take it to another query and run this. This is another transaction, a separate window. What's happening to this transaction? It's waiting. Waiting for what? For the lock to be released. The other database is basically locking them. What type of lock it's using? Exclusive lock. Okay. Of course, if I want, so the default is by default the database respects exclusive lock, and other transactions are not allowed to read data that is locked because they might run the risk of dirty reads. But if you insist and you want to do it your own way, if this is a report you don't really care too much, so you can set isolation level, read uncommitted. Okay, maybe I'm misspelling it, so let me just set isolation level, maybe one word. Okay, Mr. Google can help me. Okay. Set isolation level, read uncommitted. So if I set this like this, okay, here, read uncommitted. Why is this? Didn't like it. Okay. Sorry, it's just syntax. Read uncommitted. Set transaction isolation level. Set transaction isolation level, read uncommitted. So what do you think will happen here? So as you can see, I can read this, and this will be read from if I read this, it's coming, and it's coming from the data file. No, shouldn't be. Okay. Maybe some checkpoint, automatic checkpointing has happened or something. So it's answered just from the buffer. Maybe that's read if it's from something else that's going on. So let me show you here. What's the time? What was the updated date? You see here, it's 809. Okay. So this one is it might be a dirty read. So let me go back here, and I changed my mind, and I don't want to commit. I want to roll back. So how the database will roll back those changes? Using the log file. So there is no magic. In my buffer, in the buffer, in the memory buffer, or in the in the data buffer. What do you call them? And yes, in the buffer, which copy do we have? The changed copy or the original copy? The changed, the one that I updated. Okay, so database does not keep multiple copies. It just goes to the same copy you have read. It goes there and change it, and the changes are in memory. Now, if you roll back, how can you roll back? Because you have already changed it in memory from the log. So you bring the log and you undo the changes, because in the log you always store what is the data item that has changed, what was the old value, and what's the new value. So you can use it for undoing. So have a look at this. When I roll back, here is a rollback. and basically only the log has been affected. So the log also records the fact that this transaction has been rolled back. So when we come back and replay the log, we roll back. The transactions that are rolled back, we ignore them. We don't replay them because they don't make sense to replay them because it has been aborted. Okay. Now, if I go back to this, have a look. This says 809. Let me clear this. If I read this again, it says 801. This is basically the dirty read. So because this transaction did not respect the isolation level of the default isolation level, which is called a read committed, only read the committed, because it did not respect that and it lowered the isolation level, it ran the risk of having dirty data, and that's what happened. T1 has rolled back, and T2 read data that has been rolled back. It is kind of clear? So now let's back to the slides. I'll just go now. Okay. So from what we just discussed, so the log, thanks to the log files, database is able to achieve atomicity by supporting the ability to undo in case the transaction is aborted. It's also able to do durability to bring the database to a consistent state before a failure or crash happens. That's basically that's what a log file helps the database to achieve. So atomicity and durability is achieved using durability is achieved definitely using log files. While atomicity, there is a collaboration between the concept of a transaction. Concept of a transaction alone is not enough. You have to have a log of changes. So transaction is just helps you to kind of having a programming abstractions to tell the server where do you start the transaction, where do you finish. What do you want to do with the transaction? You want to commit it or roll it back. But really, the underlying mechanism that enables this rollback is the log. So without a log, you cannot achieve atomicity. That's the key idea here. Now, these are the type of failures that a database management system can face. So there is a transaction failure. So one particular transaction you are trying to run, it has a couple of statements, and one of the statements has a logical error. Maybe in one of the statements you are dividing by 0. Or maybe one statement is trying to change, let's say, the balance, and it's putting the balance to negative. And maybe there is a constraint on that balance, it should not be negative, and an error gets thrown. And when there is an exception, basically, you have to be able to undo it, to undo the whole transaction using the log file. So first type of errors, easy to handle using what we already discussed, the concept of a transaction and maintaining a log file. Another type of another type of failures is a system failure. For some reason, there is memory corruption, or there is a bug in the operating system or in the database itself. In the system itself, somehow it restarted, or there is a power outage, or there is somehow the database has had to kind of reboot. It crashed and they need to reboot. In this scenario, also the log files are enough to recover. When the database comes back, when you restart the database, it will replay the log and you will be able to recover. Now, there are other type of failures where a recovery using log is not enough. Let's say a media failure, a disk crash, like the head that reads. Sometimes it crashes. And if it crashes, basically the whole disk is no longer accessible. Most of us have experienced this issue. Of course, it gives you some warning. It become too noisy. But if it's a server, if there is no strong monitoring tools, you will not kind of detect it. So if there is a disk crash, it's unrecoverable. And basically, if you have a transaction log or this stuff will not help you. You must have some backup. So taking a regular backups is a must in a database management system to be able to recover. So when you take a backup, so usually most of the time you take a full database backup, let's say overnight, and maybe during a time where the database is not that busy, because taking a backup takes some resources from the server. Now, so you take that backup, let's say overnight minimum, and then you take a regular backup, at least let's say hourly backup, you take the log backup. So when there is a crash or there is some problem, of course when you take the backup, you don't store the backup on the same server or on the same disk. Otherwise, it will be also lost if there is a media failure. So you put it on some other server or in a cloud or some. The more you put it outside that infrastructure, the better. Or you might have multiple copies. So login does not answer all type of failures. That's what this slide is trying to say. The login only helps you with these two types, kind of transaction failure. This is failure in the code that the developer has wrote themselves. Here, system failure, some failure that happens outside the application code or the SQL that the actual developer has wrote. So these, no problem. The log file will help you recover. Now, if there is more than this, like some disk lost or crash, then you must have a backup. Otherwise, you're in a big problem. Now, if there's a catastrophic failure, like fire or flood or something, then even that backup that is local will not help. So you have to have some kind of geographically distributed backup. And we will talk a little bit more about this. So that's what the big story of recovery. So recovery for kind of smaller problem, a medium problem, and huge, big problems. So each one has different strategies. Of course, backup is not the only solution. There are also mirroring. You can take a server and create a mirror of it. Of course, here the choice is based on the value of the application, the criticality of the application for your business. So the more critical it is, the more you have to invest to provide high availability. So to provide high availability, backup might not even be the best option, because backup will take a quite significant time to recover. You need to set up a new server or maybe change the disks and then restore the backup, restore the logs, and that can take hours. So if the business application or the business you have at hand does not allow such a long time for recovery, then there are other solutions. Of course, more expensive solutions, where, for example, you might have a mirror. So you have two servers that one server is live, the other one is on standby. And what you do, again, thanks to the log, all you do, you take this log and you ship it to the other server and you restore it there. Okay? And using the log, you can keep these two databases up to date. Of course, the second database is not live. It is on standby. So if there is some problem happens, all you do is just a matter of applying the last log that was not applied. In case there is a last log it's not applied, you apply it and you switch to the other database. So the recovery is kind of almost instantaneous.
It's not in the case of media failure?
In case of media failure, yes. So let me, I can show you this, although it's not enabled on our server. We have a poor man server. So something like this. So you can go to the database, properties. There is mirroring. Mirroring, as it says here, we basically specify the address of a mirror server. So you have kind of two servers, and oh, sorry, I'm not showing you this. Yeah, here. So let me just go back. So here it is. Yes, so there is mirroring, where you have two live servers. What I mean by live, they are all both up and running, but one is active, which means it's receiving the requests and executing them, and one is on standby. And you tell the server, periodically take the, or not periodic, in mirroring, it's almost real time. Whenever I push some changes to my live database, I also push kind of a copy to the other database. So both databases are mirror of each other, but not both of them are live. One of them is live, one on standby. So this is one solution. The other solution is called log shipping. Of course, it's not here. Log shipping, kind of, it was there prior to mirroring. Mirroring a little bit. Mirroring it takes very much shorter time to recover. Log shipping is nothing but periodically taking a copy of the log, pushing it to another server, and that server kind of replays it. So using the log as a way of recovery, another level of recovery through having multiple copies, either through mirroring or through log, what is known as log shipping. Okay, so if something goes wrong, it's just a matter of switching the load to the other server. So you don't need to wait for the recovery to restore the backup and restore the logs and so on. Okay. So that is the idea. So since we started talking about this, let me just jump there, because we might not have the chance towards the end. So these are the main high availability failover options that you have. So you could either have a cluster. Okay, let me show you. This is maybe a better one. So a cluster of machines, but in a cluster, you basically, because remember, database, you could have multiple database servers, but they share the same database, same physical storage. So in terms of physical storage, you have one. But in terms of servers that will receive the requests and process them, you can have multiple. This is basically failover cluster. It will help you if one of the servers goes down. In the data here, you are investing in some very high availability technology like a NAS, or a SAN, which is the storage area network. You are investing in some storage area network, and this storage area network has at least, let's say, RAID 5 or RAID 10. So you are protected against at least a couple of disk failures. So basically in database, in this cluster, you have multiple servers, but shared data source. That's basically one solution, which is the failover cluster. The other solution is data mirroring. Whenever there is one live and one is on standby, and the live one is always pushing the transactions as they happen to be replayed on the standby version. Another kind of an older technology and much cheaper to set up is just to do a log shipping. Periodically, every hour or every half an hour or whatever you want to do, you basically schedule the log to be backed up, and you send it to the other database and you restore it on the other database. Of course, this is you can script it, you can automate all of this. There is also now with the advancement of the cloud, you could have one local copy in your data center locally you are using, and then you have a mirrored copy on the cloud. So, and the cloud, when I say cloud, it could be in a different, definitely in a different place, maybe different country. So even if there is some disaster, you can still recover. Okay? So the investment here, how much you want to invest, it's not just you go for the best. That's not, business don't basically work that way. You have to justify the investment. Is the application worthwhile investing such having such investment of cluster or mirroring or just log shipping or just a normal backup? Is a normal backup enough, or do we have to go for more sophisticated? So that will really depend on how critical the application is, how long it takes to recover, what is the tolerated time for recovery, and so on. Okay. So for example, something like Blackboard in our environment, it's critical to have it up and running all the time. So you can invest in some more sophisticated high availability option. While something like HR, although it is important, but you don't need to have that level of high availability. It can be done even a couple of days. Doesn't really matter. Okay. Maybe except when you have a payday, but it doesn't matter. People can wait. It's not the end of the world. So you see, like, depends on the criticality, then you select the best failover option. So, because basically the less the time to recover, the more costly the solution is, in terms of licensing, in terms of setup, in terms of hardware requirements, and so on. Okay. So I think we can, if you want, we can. Okay, let me just cover this quickly and then we can take a break. This is an example of recovery. I think by now you're already familiar with this. So we already seen this. This is a concept of a transaction that have multiple operations, and we want to put them as one unit. So if there is a failure in the middle, you should be able to recover. Sorry, you should be able to undo. And for you to be able to undo, you have to take a lock. I already explained this very well. This you already now, hopefully you understand very well through the demo and discussion we had. So database has two major files that are on disk. There is the data file and the log file. And typically they are on separate disks. For performance, for two main reasons. One is performance, because two disks, you have less contention on resources. So you have more parallelism. And also, in terms of recovery, you take care of this log, as I explained, more than the data. Because the data, you can recover it from the last night's backup. But it stores whatever you have done since the last backup. Okay. Now, any operation you are trying to do, either reading or writing, the data that you want to read or write must come from disk to the data buffers. Now, and then any changes are done in place. This is a very important word here. When a block change, we don't go and say, okay, let's keep the old block and let's create a copy and do the changes in the copy. If we change our mind, we throw away the copy. That's one design, of course, but very rarely used. Most databases, they will use in place update. So when I change, I basically change the data that I read in the buffer. But I record the changes in the log. The log, of course, it is treated the same as the data block. It is a set of blocks that are pushed to the disk, and they are also managed as blocks. Okay. So now, when the data buffers are modified, this is very important. When the data buffers are modified and the transaction commits, we don't go ahead and flush them to disk or write them to disk immediately. We do it later. It is a deferred update. When does the database do this operation of pushing the dirty blocks from the buffer to the disk? Two times it does, in two scenarios. Either it runs out of buffer memory and it has to basically throw away some of the pages, so it has no choice but to push them to disk. That's one scenario. The other one is checkpointing, periodic checkpointing, or programmer, some smart program, although we should not interfere in the database how it works. Let it do its own work. But in case, you can explicitly ask for checkpointing. What checkpointing means? You are asking database, take the dirty pages and push them to disk. Whether the transaction is committed or not, I want to take those to disk. And what's the advantage of checkpointing, as I explained? What's the motivation to do checkpointing? Minimize the time for recovery. Because if you don't have checkpointing and the database restarts and you need to recover, the redo and undo should start from the start of the log until the end. And that could take very long time, especially if you have a busy database or you have not truncated the log. By the way, the log can grow. And what you do, you have to periodically truncate it. When do you think it is safe to truncate the log? Truncate means you basically shrink it, remove all the entries before the last successful checkpoint. That's what truncating means. So when do you think it's safe and you should do truncating the log? Half of the changes? Okay. When the data, that is very dangerous. It could be committed, okay? And then basically no, what I mean, no, let me see. No, basically, just to summarize quickly, because I lost the point. You truncate the log when you take a full database backup. That's the safest time to do it. So when you take a backup, let me just show you. No, backup is something different. So let me just explain this. This is very important. So some people, their job, when they give you their business card, you will see database administrator. Okay, they don't do any development. They don't write any code. Maybe some scripts. That's all. So one of their jobs is to do what? Regular backups. But if something happened, they are responsible. They will bring them to account more than the developers. Okay? So one of their tasks, of course, they don't do like this. They will script everything. They have more sophisticated tools and so on. But this is like this, the poor man backup. You just go to the database and you say backup. Okay, when you take a backup, there are different types of backups. There's a full backup, which means you take the whole database, the data file and the log files, and you back them up. You kind of zip them and compress them and create an external file that you can put in floppy, or you can put in Dropbox, or you can put in the cloud, or wherever you want to put it. Then that file, you can use it to restore the database at the time when you backed it up. So when you take a full backup, I think by default it's basically truncate the log by default. When you take a full backup, because you have everything already in the backup, the log has no value now. Keeping this huge log, you will not need it, even if there is a recovery. Because you have, when there is, like, let's say, disk crash, you have to bring the last backup, and then replay the log. When you replay the log, you only replay from the time of the last backup until the crash happens. So basically, when you take a full backup, the log gets truncated. Yes? You can also, so usually what people do at night, they will take full backup. These are not Mickey Mouse databases. These are real huge databases. They can take hours to backup. So they don't want to do it during the day. They will take a full backup at night, okay, and take care of that backup. And then there is differential. It's just the delta between the last backup and the time you do differential backup. Okay. In the differential backup, you have the option, although it's disabled here. Let me see.
Can we completely recover using the differential?
No. You have to, basically the way it works, differential is you do a delta of the changes. You are basically backing up the delta of the changes. So the reason why you only backing up the delta, it's much faster to do the backup. So you might do this during the day. During the day while people are working, maybe there are some periods where it's not as busy. So you schedule a differential backup and you keep it. Now, if something went totally wrong with the database and you have to restore it, you restore the full backup, and then you restore all the differential backups, then you restore the log to bring the database back to it. That's the idea. Let me see, where is my backup, my log? Yep. Okay. So that's what I want to say. Like okay, let's stop here. Just to summarize this, what I want to say, typically the best time to truncate the log, basically shrink it and get rid of the entries, is when you take full backup. Because when you take full backup, you should be confident of that backup in the cloud. Of course, you verify it also. You verify that the backup. It's part of the most of the backup systems, they will make sure the backup is working. Because if the backup did not back up properly, it can be a big problem. So when it's backed up, the systems usually can verify it. So let me just, so here tasks, backup, one of the options here. Is verify backup, perform checksum, continue, whatever. Of course, in real life, people use much more sophisticated tools than this to manage the backups. All right. So let's take like 10, maybe 15 minutes break, and then we come back and resume this. Okay. So basically, this is a summary of what we have seen. This is what a transaction log allows us to do. So first of all, since we have deferred in-place update, I hope this sentence is clear. Deferred means the data blocks are not immediately saved to disk when we commit the transaction. In place means when a buffer data block is changed, it goes and replaces the disk block. So we don't create kind of multiple copies of the blocks. We just override these blocks. So the only way to recover, because of this deferred in-place update, the only way to recover is to keep a log. So a log has data prior to modifications. It has the before image and the after image. So for each item that has changed, it keeps the value before change and the value after change.